What's up, guys? Welcome back. I just wanted to, continue my series on the foundation exam questions. I know that's coming up pretty soon for you guys, and I got some positive feedback from the last video, so I just wanted to I wanted to focus on a specific topic of the foundation exam. It was the dynamic memory management part, and there's really not that many. I think this is honestly the easiest part of the FE, just because there's not that many different types of DMA questions you can ask. Like, there's pretty much free some sort of list, create some sort of list, and then, like, other than that, those are the two main ones. Sometimes they'll be like, where are the memory errors in the issue, like we're looking at this one on the screen, or also they'll maybe like do some dynamic memory allocation, but they'll also use stacks or trees or something, but it doesn't get too complex in my opinion. So I want to do actually a few questions for you guys today. I'm going to start with this one. This one was on my foundation exam. It was different. This was the first one like this that I've seen from studying the other one, so it kind of caught me off guard, but at the end of the day, I still think it wasn't bad at all. So the question is, the following function has 5 memory management issues, each one occurring on a different one of the 17 labeled lines of code. Please clearly list which 5 lines of code have the errors on the slots provided below. Please list exactly 5 unique lines, numbers in between 1 and 17, inclusive, and an automatic grade of 0 will be given to anyone who lists more than 5 line numbers. Okay, cool. So we're looking for memory errors. Like, what's a memory error? It's pretty much, when you have a memory leak, that's one of them. When you stop pointing at an allocated block of memory. We have like seg faults, so if you go out of bounds in memory, or anything else that can cause you to seg fault. And then we also have freeing something that doesn't need to be free, which isn't that bad of a memory error. I don't think your computer will crash if you free a pointer that is null or something. But I guess it is technically considered a memory error. Okay, so let's just start from line 1. So first we have a variable being declared, n equals 10. This is static, so we know we don't really have to worry about this line. It can't, there can be no memory leak here. And then we're going to declare a few pointers. We're going to say, okay, they're integer pointers. They're going to point at P1. One is going to be named P1. One is going to be named P2. One is going to be named P3. And the last one is going to be an integer double pointer. Okay, so it's an array of pointers. And then we have this, again, another static declaration of a test string. So the only memory issue we would have here possibly is maybe if we try to access out of bounds of the string, so we'll keep an eye out for that. And then we create a pointer here named string2. It's a character, so it's probably going to be interacting with this guy, I'm assuming. And then we try to do the string copy. So remember, what string copy does is it does the second into the first. So it's trying to string copy string 1 into string 2, but string 2 was never allocated, so this wouldn't be possible. So that's our first issue. So line 4, that's problem number 1. It's like, okay, so sorry, not line 4, it'd be line 5, because you can't do that. And then now we have two malloc statements here. We have P1, which is an integer pointer, and it's going to malloc it to hold 10 ints. Alright, there's no issue with that. And then P2 is also an integer pointer, and that's malloced in an array that holds 10 ints. Now, remember that now both of these pointers are both holding a memory address of an array of size 10 somewhere in memory, and they must always be pointing at that array unless it is freed beforehand. Okay, so if P1 or P2 change, the memory address changes before either one of them are freed, or without holding on to that memory address somewhere, we know that's going to be an error. It says, alright, now we have this for loop here, and this for loop is just putting random numbers into P1 and P2, and all we really have to watch out is make sure we're in bounds of memory. And we know that n is 10, and it's less than 10, so it goes from 0 to 9, and that holds 10 integers, so that's perfect. So the for loop is not going out of bounds memory. But then look at this guy over here. P2 equals P1. Remember, P2 is holding its own block of memory. So when you set P2 equal to P1 without freeing it first, Now P2 is pointing at P1's block of memory and not pointing at its original block of memory, and now we have a memory leak. You know, there's no way for us to access that memory anymore because we didn't point anything at, at that array before we moved P2, and also we didn't free P2 before we moved it. So now we have a random block of 10 integers that we can't access ever again. So that is memory leak number 2, or not memory management issue number 2. So that would be on line 10. So right now we have line 5 and 10. It says okay, cool. And then it's going to dereference P3, and it's going to set it equal to 50. Okay, so let's see what is P3. P3 is an integer pointer, but here's the issue with that. P3 is not pointing. It is a pointer to an integer, but it's not holding a memory address of an integer, if that makes sense. So we can't dereference P3 and set it equal to 50 because it is not pointing at it. You know, it is an integer pointer, but we would have to point P3 at something like n if we wanted to actually, if we wanted to actually change whatever P3 was pointing at. So that's another issue. So we have line 10 and 11. It's like, okay. And now let's look at line 12. So P4 is malloc to a size of 10 integer pointers. So that is valid because P4 is a double array, so it's an array that holds integer pointers. So when you malloc, you have to do size of int pointers. Okay, sweet. And then it's going to say, okay, now it's going to loop through that array, and it's going to set P4I equal to -5. And we know that this is an issue because remember, P4 is an array of integer pointers, and integer pointers hold memory addresses. So if we set a pointer equal to -5, that's not a valid memory address. That is, we would have to almost like dereference that pointer again to get to an actual integer if we were pointing at 1. So yeah, so this, you can't set a pointer equal to just a random number. It has to be set equal to a memory address. So that's an issue. So we have line 14, and then we're going to free P1, okay, and then we're going to free P2. This is another issue because remember that P2 is pointing is pointing at P1. So if we free P1, now P2 is pointing at garbage memory address, and it tries to free it again, which is an error. So let's see if we have 1, 2, 3. Let's see if we have 5 of them. So our first issue was line 5, and then our second issue was line 10. Line 5, we try to string copy like a not allocated array, so that's the issue. Line 10, we have a memory leak because P2 loses its array that it's pointing at. Line 11 is trying to set in a pointer, it's trying to dereference a pointer that isn't pointing at anything. So that's another one. That's 3 so far. And then we have line 14, which is trying to set it's trying to set a pointer that holds a memory address equal to -5, which is not a valid memory address. And then we have line 16, where we're trying to free an extra. We're trying to free an extra, we're trying to free something that's already been freed. Sorry. So that's 5 of them right there. So that was that one. Not too bad. So let's get to the other 2 types that I was talking about. So now it's really it's going to ask you to either allocate memory or free memory, pretty much, are the coding questions. So let's look at this top one. And it says, all right, suppose we have an array to store all the holiday presents we have purchased for this year. Now that the holidays are over and all the presents have been given out, we need to delete our list. Our array is a dynamically allocated array of structures. Okay, so we know that. We're going to be freeing an array of structures. An array that contains the name of each present and the price. The name of the present is also dynamically allocated. Okay, so we know now we have 2 dynamically allocated things. So we know we're going to need to delete both of them. And then the present is a dynamically allocated string to support different lengths of strings. Okay, that makes sense. Write a function called delete present list that will take in the present array and free all the memory space that the array previously took up. Your function should take two parameters: the array called present list and an integer previously took up. In an integer. Okay, don't. So I'm pretty sure it's like it's an integer of the number of presents. Oh my god, that's so your function should take two parameters: the array called present list and the integer num. Represent the number of presents in the list and return a null pointer representing the now deleted list. Okay, that makes sense. Note that the array passed to the function may be pointing to null, so that case should be handled appropriately. Okay, fantastic. So he kind of already told us about the null thing, so we have to check for null. That's going to be easy. So let's just do that first. So we're going to go if what's called present list equals null. We're just going to return null. Perfect, because the present list doesn't exist, so there's nothing to free. Now it says, okay, so now, what do we have? We have an array of structures, and inside of that structure, there's a dynamically allocated name. So we need to go in, remember, we have to go from inner to out. We have to free the name before we can free the structure, if that makes sense. So let's free all the names. So we know that there's a num amount of presents, so we're going to have a for loop. So I'm just going to declare a variable real quick. Oh, that's always declare your variables at the top because it's prettiest that way. Int I equals 0. There we go. Okay. Oh. Go 4 I 0 I is less than num because that's the number of presents, and then it's going to be I plus plus. Okay, and so this, we're going to go through every present, and we're going to free the name. So we're going to go free, we're going to go present list I dot name. Remember that when you use the brackets and put a number in it, that's the same as dereferencing a pointer, so we always use the dot instead of the arrow. Okay, so free present list dot name, fantastic. So that's gonna free the present, the name. And then after this, all the names are freed, and now we just have the list of presents, and we can just free that, and then we can free the present list itself. Then what does it want us to return? And return a null pointer. Okay, and then we can just return null. Easy as that, you know. That's what I'm saying, like, once you get the hang of this, it's literally a bunch of questions structured like this. This is the freeing one, and like obviously it can be a little bit more, you know, some of them can be a little bit more tricky, but if I would have a really good basic understanding of a question like this before you like try to, you know, start to understand the trickier ones. Okay, now let's do the third type of question. Suppose we have a structure to store information about cases of juice. The structure is shown below. The name of the juice in the case is statically allocated. The structure also contains the number of containers of juice in that case. Complete the function below so that will take two parameters, the name of the juice and an integer. Your function should create a new case of juice by allocating space for it, copying in the content specified by the formal parameters into the struct, and returning a pointer to that new case. You may assume that the pointer new name is pointing to a valid string storing the name of the juice, for which memory has already been allocated and is 127 or fewer characters. Okay. So we're getting a new name and a new number, pretty much, and it wants us just to create a case of juice. Let me just read that again. Structure below, the name of the juice is statically allocated. The structure also contains the number of containers of juice in that case. Complete the function. Okay, below that will take you from the juice and enter your function create a new case. So remember, case. A new case is one case of juice. I just wanted to make sure we weren't making like an array. So we have a singular case of juice that we need to create pretty much. So that should not be bad at all. So here's what we're gonna do. We know we are going to need to allocate a juice case. Like if we look at our function that he gives us, it's returning a pointer to a juice case. So let's create that. So we're gonna go struct. So we have to write struct because he doesn't type def it. So it's like struct juice case, GUICE case, and then I believe it's new juice, new juice equals, and then we're gonna have to malloc, and it's gonna be size of, and then did he really not type def it? Dang. Okay. So size of, I'm pretty sure we have to write struct juice underscore case and I'm pretty sure that should be it right there. So size of struct juice case, and then we have that. So we made the new case of juice. Now we just have to insert the name pretty much into the name spot, and also the number. So now we can go new underscore juice, and this is a pointer. Remember, new juice is a pointer to a juice case, so we have to use an arrow num bottles num underscore bottles equals new number, and that's gonna insert the number into the number of bottles, and now we just need to get the name in. So we're gonna do the same thing, new underscore juice, and then we have to do the arrow. Oh, and so we are putting in so we're gonna copy the name, the new name into the name. So let me just finish writing this. So arrow name, and so we're gonna have to do a string copy. So I kind of am writing this backwards. So let me do it like this. Then I'm gonna go strcpy. And then we're string copying our new name. New name. So remember, we don't have to malloc name because it is statically allocated for us already. So we just really need to string copy that in there. And then I can close this guy, and then I can return our new juice. Perfect. Yeah, so really not that bad. You just create the new juice case, insert the number, insert the name, and then return it. So these are the two main types of questions that I've seen on past foundation exams. I would really, find these questions and get comfortable with them, and then try to find the more advanced questions and try to work on those. Thank you guys. It's been a pleasure this semester, and we're almost there. A few more weeks. Keep the spirits high. If you have any questions, feel free to send me a message on Discord or send me an email. Thank you.